Since we know we can do that solving using the one-line command unknown temperatures a/b, that'll solve the form we just talked about, our goal now is to build the A and the B matrices technically. A a matrix, B a vector is how we usually think of them. Let's take a look at the matrix A and the patterns hiding in it. So I would encourage you to do this yourself. Look for any elements that seem common and then tie that back to the geometry in the layout of these numbers here. We already talked about some elements though. T1, T6, T11, those are going to have -3s in front of them. Everything else along the diagonal, all the other cells, if we look at them, are going to have 4 neighbors, so they're going to have -4 associated down their diagonals. So we're going to have -4 down the diagonal, except T1, T6, T11, counting by 5s up till T21, have -3s. And so those are actually row numbers. What about the other patterns? Let's go back to the matrix for a moment. We see 1, 1, 1, 1, oh, 0. Why is that 0 there? Well, if we look at the columns, this is saying T1, when we look at the balance for T1 is connected to T2, absolutely. T2 is connected to T3, T3 to T4, T4 to T5, T5, oh wait. T5 is not connected to T6 because T6 is down on the next row. So we're going to have 4 1s, then a 0, 4 1s, then a 0, 4 1s, then a 0. So above the diagonal, we're going to have all 1s except T5, T6, and T10 and T11, all the way down to the end of the cells. And also the same pattern appears in the under diagonal. So we're going to have 4 1s, then a 0 here, and that's capturing the fact that T6 and T5 are not connected when we look at T6 as our main source of heat flow. So when we look at T6, that's building this equation. It's adjacent to T1 and adjacent to itself, or includes itself, and then includes T7 as the next one down, but it certainly does not include T5. So the same thing for the below diagonal as well. And last but not least, if we look at this other band here, this is T1 connected to T6. Let's scrape out our values here for a moment. T1 to T6, T2 to T7, T3 to T8, T4 to T9, T5 to T10, yes. T6 to 11, everybody has a downstairs neighbor until we run out of space here. So we're going to have all 1s when we are 1, 2, 3, 4, 5 away from the diagonal. There's going to be an all 1s, 5 to the right of the diagonal, and all 1s, 5 below the diagonal. That's going to be the reciprocal, equal and opposite part of a heat transfer. Here we have in row 6, we have an element that's 1, 2, 3, 4, 5 back, or 1, 2, 3, 4, 5 down. We can construct these in different ways, but this off-diagonal sequence is going to also be all 1s. And that's it. By the time we've done that, we've covered our left to right neighbors, that's this stuff. We've covered our down and up neighbors, that's those ones. And we've covered the how many neighbors do we actually have at each cell with this pattern here. 3 patterns defines the entire A matrix, which is pretty sweet. Let's take a look at the B vector. The B vector only has elements when one of the contacts is the environment outside. So the B vector is going to have a -20 for rows 1 to 5. It's going to have a -120, and it's negative again just because of the way we wrote out our equations. When we had the +20 equals 0, we move it to the other side, it changes sign, becomes negative, and that's true for all of these external temperatures. negative 120 for T5, T10, T15, up to T25. And we're also going to have for the bottom row T21, 100 degrees, which is negative 100 when we put it in equation form, for T21 to 25. And these are additive. In other words, T5 has, the row for T5 has a minus 20 and a minus 120, so it better look like negative 140 by the time we're done, and T25 had better look like minus 120 and minus 100 for minus 220. So we want a way to handle both of those, or all three of those scenarios, but make sure that we're accumulating things as we go. Well, hey, that's not too bad. And hopefully in the back of your mind, if you're looking at these patterns, you're thinking, well, if this is a 6x6 or an 8x8 grid, we could tweak this just a little bit and get all the same kind of effects and increase the resolution of our image for this heat and temperature distribution. So keep that in mind as you're doing the coding as well, is the 5x5 grid is not the be-all and end-all. We're going to want to head towards a finer grid as we move forward, building off of this foundation. So how are we going to do this? We're going to get into the coding shortly, but the building blocks are going to be what you'd expect, creating a blank template to work with, all zeros, because most of the elements in the A matrix and B vector are zeros. And then what we're going to do is indexing in a matrix. And we're going to specify the values. So at row 1, column 1, we're going to put a minus 3. At row 2, column 2, that would be a second element down the diagonal, we're going to put a negative 4, and so on. Of course, we're not going to want to do that explicitly for every location. We're going to use loops. We're going to build our right-hand side as 25 rows, 1 column for our B vector. We're going to be able to do some calculations with that as well, leading up to the solving T equals A slash B once we've built and filled in the A and B matrices. Let's try that now, starting with the foundation that is in W3_1, and we'll see how we do it.